Hello everyone! Today we're going to talk about momentum. But first, before we officially start, let's go back to the basics. Do you know what quantity momentum is? Yes! You're correct! It is a vector quantity. So don't forget to add that arrow on top. But before we begin, let us differentiate a scalar and a vector quantity.
Scalar vectors measures size. When you're finding out how large something is, you describe it as a number. It can mean something really small like the mass of hydrogen, or something really big like the temperature of a solar flare. Again, scalars describe how large something is, something with magnitude. On the other hand, vector quantities take into consideration the direction. Quantities like displacement and force are very particular about the way of the object's motion. Think of vectors as arrows. A vector quantity is any quantity that has a magnitude and direction. Such are displacement or velocity and many other more.
Okay, so now we know it is a scalar quantity. Do not forget to add that arrow on top.
Moving on, what is momentum? Let me simplify it for you, so you don't need to research about it.
Momentum is literally the product of mass and velocity. Yes, you heard me. It's that simple.
Mass literally means whatever you are made out of. Measure of the amount of matter inside you. So, for example, you weigh 50 kilograms. Well, that's your mass. Simple, right? The unit of measurement for mass is kilograms.
For velocity, on the other hand, it's literally speed but with direction. Simple, right? Please do not be confused with speed and velocity. Both things seem the same but are somewhat different from each other. One is a scalar quantity and the other is a vector.
And speed is just simply the rate of change of position of an object. It has no direction, only magnitude. So we can conclude that speed is simply just a scalar quantity.
For velocity, it's literally speed but with direction. Here's the equation for velocity. You also have to take into consideration the change in displacement and the change in time. Obviously, as you change in position, you move, you travel a distance or displacement. Obviously, time is moving as well. The triangles are technically the change in. Please don't be afraid of it. There is no trigonometry or geometry associated with it. The unit of measurement for velocity is meters per second.
Now we know how to get mass and velocity. All we need to know now is to multiply them together in a momentum. The unit of measurement for momentum is kilogram times meter per second. We got that from momentum and velocity's unit of measurement.
The law of conservation of momentum is as follows. M1 V1 plus M2 V2 is equal to M1 V1 prime plus M2 V2 prime. The primes denote that a value is final. Consequently, you can affix O's and F's to indicate that a value is initial and final, respectively. This law states that the initial momentum will be equal to the final momentum because just as energy is concerned, momentum too is neither created nor destroyed. Thus, the input will be equal to the output, given that the system is isolated and no other external force is acting upon the variables.
Stay tuned for part 2. In the next video, we will be tackling about inelastic and elastic collisions. Stay curious, my friends. See you out there!